Welcome back to my today's session on electromagnetic field. Today we are going to discuss the tutorial question bank from Unit 2. We have chosen some important questions from the question bank and today we are going to discuss these topics. So, before starting this topic, myself Dr. Sayanti Chatterjee, the Associate Professor of Tripoli Department, Institute of Aeronautical Engineering. So, we are going to the first question, which is this very simple question, but it is very much important. Demonstrate the capacitance between parallel plates when they are separated by a single dielectric medium. How to do? So first think about the two parallel plates. You can see there are two parallel plates which are drawn in this grey color and they are separated by this dielectric which has been mentioned here in the blue color, and the distance, the thickness of between these two parallel plates is given as the D. A is the cross-sectional area or surface area of each conductor. And we are assuming that what is the capacitance? Basically, according to the definition, capacitance is the ratio of the stored charge and the voltage across the plates, or the potential difference between these two parallel plates. If we connect some battery, if we connect some external battery between these two plates, what will happen? There will some charge will accumulate. On the one surface, it will be positive charge, another surface, it will be a negative charge. And therefore, there should be a potential difference. And what is capacitance? Capacitance C equals to Q by V. So, already we know that what is E? E is equal to Q by epsilon A. Now, you may ask how this equation come. According to the definition of intensity, E is equal to Q by 4 pi epsilon R square. So, we can write Q by epsilon 4 pi R square. Now, what is 4 pi R square? It is if we take the surface as a spherical one, this is the surface area of a sphere. So, we can write Q by epsilon into A. So, what is V? According to the definition of potential difference, V is equal to intensity into distance. V equals to intensity into distance. So, what is intensity? We got Q by epsilon A. And what is D? D is the distance between them. Now, according to the definition of capacitance, C equals to Q by V. So, if we put the value of V, what will happen? If we put the value of V, we will write Q by QD by epsilon A. So, we will get epsilon A by D. And what is epsilon? Epsilon is nothing but the permittivity of the medium, and epsilon equals to epsilon 0 epsilon R by R. Epsilon 0 is the permittivity of the free space, epsilon R is the relative permittivity. So, this is if we have two dielectrics, what will happen? If instead of one dielectric, if we have two dielectric, then we can think that two capacitors are in series connection. Same question, but if it is little different, instead of the single capacitance, if it is coming the two capacitance, two dielectric medium, what will happen? We can think there is another, we can assume there are two types of cross-section, two types of epsilon, and we can write this is epsilon 1 and this is epsilon 2. There are two different medium. So, what is C1? C1 will be epsilon 1 A by D1. Why? Epsilon 1 is the permittivity of one medium. Say this is our green one is the medium one. So say epsilon 1 is the medium one. And we are assuming the red dot, or we can tell the purple dot is the epsilon 2. So we can write C2 is equal to epsilon 2 A. And what is why A is same? Because the cross-sectional area or surface area is same. So we can write epsilon 1 into D2, where D1 plus D2 equals to the total distance D. So as these two, you can see the same current is flowing through both capacitor. We can write that the both capacitors are in parallel. So we can write C1 is with series to C2. C1 is series to C2, and we can write total C equivalent is equal to C1 C2 by C1 plus C2. So from there, this is for the same question, same answer. Only difference is, instead if question is single dielectric medium, if the single dielectric medium, we can only prove C is equal to epsilon A by D. If the question comes for the double dielectric medium, we have to write up to this. So this is the first question. Demonstrate the capacitance between the parallel plate capacitor. Another questions from the capacitor, you can get it from the other YouTube video on the capacitance. Now we will go for our next question, which is very, very important question. Derives the Ohm's law in point form. Already we know Ohm's law. What is Ohm's law? When temperature, pressure and other physical activity remains constant, the current flows through any conducting medium is directly proportional to the voltage applied. So we know that the Ohm's law is B is directly proportional to I. And what is, then we can write B equals to R into I. And what is R? R is equal to known as the resistance. Resistance definition is rho L by A, where rho is known as the resistivity. And rho is equals to 1 by sigma, where sigma is equal to conductivity. So this is the basics of our Ohm's law. Today we are going to prove the Ohm's law in point form. Point form means this is the another name of the point form is known as the differential form. So let's start. When we are giving any field, when the field is there, electric field is there, the free electrons start moving, and after some time, one second. So when there is an electric field and we are connecting some potential or some voltage battery with this conductor, so what will happen? Some electric field will set up, and electric field is with the some free electrons, and while we are giving the potential, the free electron starts moving, and after some time it will gather or it will attain a constant velocity. This velocity is known as the drift velocity. So drift velocity Vd is directly proportional to the field intensity which we are giving to the conductor. So what will happen? We know that the Vd, what is Vd? Vd is equal to minus mu into E. If we just remove the proportionality constant, we will get Vd is equal to minus mu E. So what is mu? Mu is known as the mobility constant, and it is the proportionality constant here. Mu is known as the mobility constant, the speed of one electron to get its drift velocity. Again, from the previous discussion, we know that the current density is equals to the rho v into Vd. What is rho v? Rho v is the volume charge density, and Vd already we told that it is nothing but the drift velocity. So what is the meaning of volume charge density? Volume charge density means charge per unit volume. So we got this equation. So if we write what is J, then we got J is equal to rho v into Vd. And what is Vd? From this equation we got Vd is equal to minus of mu E. And if we write that minus rho v mu into E. So we can write rho v into mu into E like this. Rho v and mu is known as the conductivity of the conductor. So current density. So what we got? We got that the Ohm's current density is equal to depends on the conductivity of the conductor into the intensity of the conductor, and it is known as the Ohm's law in the point form. This is the question number 2. So first thing, what is drift velocity? Drift velocity means while we are giving the field, the electron starts moving and it enters at a constant velocity. And so we can tell second point, drift velocity is directly proportional to the intensity. Third important point is the Vd, the drift velocity equals to minus mu E. And what is J? J is equal to, we already discussed that the current density J is equal to volume charge density divided into Vd. Vd is the drift velocity. So just substituting the value, we got J current density is equal to minus sigma into E, where sigma is the conductivity of the medium and it is the Ohm's law in the point form. Next, question number 3. State and derive the expression for equation of continuity. This is also a very important topic. So what are the equation? Continuity equation. Continuity equation is basically two types. One is in the integral form, another is the known as the point form. Point form is also, as I told earlier, point form is also known as the differential form. So question may come in any language that the continuity equation in integral form or continuity equation in differential form. So we will discuss this one by one. First we will discuss the expression of continuity in integral form. So first we assume that there is a closed surface and in the closed surface some charge is confined. And what is the value of the charge? The charge value is Q. So what is current? We know the flow of electrons are known as current. Though we are telling the positive current, negative current, but proton never flows, only electron flows. And what is the direction of the current? The direction of the current is always opposite to the flow of charge. So we can write current I is equal to minus dq by dt. Why minus? Because the direction of current is opposite to the flow of charges. Charges means only flow of electrons. In case of EMF, the direction has the huge importance. So what is current density? According to the definition, current density means current unit surface area, because the general tendency of the charge is to lie on the surface of a medium. So we can tell that the current density J equals to di by ds, current per unit cross-sectional area. Unit surface area. What is the difference between surface area and cross-sectional area? If we cut any layer and this, after cutting we get the cross-sectional area, and the general any surface of any medium is known as the surface area. So current density is equal to J is equal to di by ds. So if we write I, what is I? I is equal to J dot ds, or we can write it as it should be better to write J dot ds. This circle means this is a closed path, and closed path means current always flows in a closed path. So it is better to write closed path integration of J dot ds. Here I have used the bold letter to tell it is a scalar quantity. Either you can give the arrow or you can use the bold letter to tell about the vector quantity. So if we integrate, if we equate this equation with this equation, both having I, this green one and the yellow one both having the I equation. If we equate these two things, we can get I equals to integration of J dot ds equals to minus dq by dt. So this equation is known as the continuity equation in the integral form. So this is the first part of the answer, continuity equation in the integral form. Now we will derive the continuity equation from the point form. Let's start. So already we got that integration of J dot ds is equal to, we can write from the divergence theorem, is equal to volume integration of grad dot J dv. We have discussed these things many times, that while we are changing the level, means from the ds means the surface integral to volume integral, we are increasing the level. What we will take? We will take the grad of the main function. Say if we want to change it from linear integration to the surface integration, we have to take the grad of the main functions, and this is known as the divergence theorem. So already we got in the previous slide I is equal to, we got this equation in the previous slide, I is equal to integration of J dot ds. Now what we are doing? We are just writing the J into ds to grad J into dv, because already we got this equation. And what is the another important thing? I is equal to minus dq dt, already discussed in the previous slide. So if we compare these two equations, we can write minus dq by dt equals to current. This is equals to current. So minus dq by dt equals to integration of grad J dv. Now what is q? Q is equal to rho volume integration of rho v dv. What is rho v? Rho v is nothing but the, already I have discussed, rho v is nothing but the volume charge density, means charge per unit volume. So we can write, if we write, take these things, just we can write in the place of q, from this equation, we are taking from this equation, we are taking from this equation, we are substituting the value from q, rho v dv by dt equals to grad J dv. So what is next? So we can write that if we take the rho d inside, we can write del rho v by del t dv. Now why we are using del? Actually del and d, we can use d also, but basically d is used for a single dimensional thing. As the volume charge density, the charge is a 3D, three-dimensional thing. So it has x, y, z axis. Instead of d, we are writing here del by del t. So del by del t by dv is equal to, we can write grad j dv. So if we compare, this is a volume integration, this is a volume integration. So if we compare these two line, dv cancel out, and we will get the delta rho v by delta t is equal to integration of grad j dv, and it is the continuity equation in point form. So if the question comes, write the continuity equation, you have to mention both. First one is the integral form, second one is the differential form or point form. Now we are discussing the question number 4, and question number 4 is a problem from this chapter. Already we have discussed a separate problem solving of capacitor in our previous lecture. Today we are taking only one problem from your question bank, which is based on the previous continuity equation. So let's do. A conducting wire of diameter 1 millimeter and conductivity 5 into 10 to the power 7 ohm per meter has the 10 to the power 29 free electrons per meter cube. When an electric field of 10 millivolt per meter is applied, determine the charge density of the free electrons. So how to calculate the charge density? Already it is given that 10 to the power 29 free electrons are there. So number of free electrons is 10 to the power 29. What is the charge of 1 electron? 1 electron charge is minus 1.6 into 10 to the power minus 9. So first question, determine the charge density. What is the meaning of 1 meter cube? The 10 to the power 29 meter cube means per unit volume, and that is the charge density. So what is the total charge of 10 to the power 29 electron? For 1 electron, if this, so 10 to the power 29 into minus 1.6 into 10 to the power minus 9, and it is coming minus 1.6 into 10 to the power 10 coulomb per meter cube is the charge density of this area. Question number 2. What is the current density? How to calculate the current density? Current density formula we have just discussed. In the Ohm's law, we are getting it Ohm's law in point form. J equals to sigma into E. So what is sigma? Sigma is given as the conductivity, and conductivity is given as 5 into 10 to the power 7. So we will write 5 into 10 to the power 7. What is next? It is given that then electric field of 10 millivolt per meter. So it is given that the intensity is 10 millivolt per meter. We have to remember, we have to take only the voltage, the volt unit. So it will be 10 millivolt, means 10 into 10 to the power minus 3 volt. So what is the current density? It is 50 into 10 to the power 4. And what is the unit of current density? Current per surface area. So it is ampere per meter square. We will discuss the third portion. what is the current in the wire? So already we know current density. So I is equal to J dot S. What is J? J we have already calculated 50 into 10 to the power R square. What is S? As this is a conducting wire, the surface is circular, we will take as pi R square. So what is pi? It is pi. What is R? The diameter is given as 1 millimeter. Okay. So diameter is 1 mm. So what is the radius? Radius is 0.5 mm. But we have to change all the units in meter. So what will be the value? 0.5 into 10 to the power minus 3 meter. So pi R square 0.5 into 10 to the power minus 3 square. So what is current I? 50 into 10 to the power 4 into pi 3.14 into 0.5 into 10 to the power minus 3 whole square, and the unit is ampere. So this is the next question. Next we will discuss the question number 5. This is a very important questions from this chapter, and this is the boundary condition between the conductor and free space. So while this question may come between the conductor and dielectric, same answer but little change that I will mention. So what is boundary condition? When an electric flux passes from one media to other media, this is not like electrical flux, magnetic flux can go anywhere. So the general tendency of the electrical flux may pass from one media to another media. Say we have a overhead lines. So while current is flowing in the overhead lines, it will create some field. And the field is not confined in the conductor only. It will confined in the surrounding air or surrounding medium. Similar example we can take when a transformer is immersed in a transformer oil. Transformer oil is a very good dielectric. So transformer, when current is flowing in the transformer, so what will happen? Some flux will generate. Maybe magnetic flux, maybe electromagnetic flux or electric flux. So the flux is moving from transformer conductor, means copper, to the transformer oil. So this is the condition, one conductor, because we know copper or aluminium of the overhead lines are the good conductor. So conductor and free space. When an electric flux passes from one media to another media, their characteristics change, and the condition existing in the boundary is known as the boundary condition. When the flux is leaving the surface of the conductor and moving to the another free space, it is the conductor and it is the conductor medium. When it is moving the conductor medium and go to the air or vacuum, so this condition is known as the boundary condition. So while we will discuss the boundary condition, we will take some assumptions. First assumption, field intensity and flux density inside a conductor is 0. As the general tendency of the charge is to lie on the outer surface of the conductor, that's why we will assume that field intensity and flux density inside a conductor is 0. Next, we will also think that the charge only appear on the surface. So what will happen? The charge density is also 0 inside a conductor. So we are getting 3 points. First one is the field intensity and flux density is 0. Charge will lie only on the outer surface. And third point is the charge density within the conductor is 0. So you can see the figures, check it carefully, that this is our main figure. This is the main figure. This is the boundary. This half circle line is the boundary. This is the boundary condition. So this inside is the conductor. This inside of this boundary, this lower portion we are assuming as the conductor. And the upper portion we are taking as the, what is this? This is the free space. We are taking it as the free space. We have drawn here different type of diagram to tell the thing. So this, if we draw it, if we take a small portion and we can take it like a rectangle area, or we can take it as a Gaussian plane. Gaussian plane means cylindrical. Here we will go for the rectangular coordinate. So we will take a small rectangle area. So the rectangle, you can see the upper portion of the rectangle is in the free space and the bottom portion is within the conductor. Okay. And what is this? This is the surface of the conductor, or we can tell this is the, what is this? This is nothing but the boundary. So we will go for the next one. So this is already we have discussed. Now, so when there is a charge, there should be some intensity. When current is flowing through this conductor or through on the boundary, charge is there on the surface, means charge is always on the boundary. So there is some intensity E, and E can be dissolved into two components. Number one is the tangential component. If the intensity is in this direction, if current is flowing and field intensity in this direction, there is one tangential component E tan is here. You can see this is the E tan. And similarly, one normal component is here, and we can write it as the En. So the green one is the tangential component and the green one is the normal component. So we can write, we know that the E dot dl equals to 0. Why? Because when we know the KVL, what is the KVL? Current in a voltage in a closed path equals to 0. So if we take the voltage in this closed path, what will happen? As there is no external voltage source, we can write potential drop AB, VAB plus VBC plus VCD plus VDA equals to 0. This is the basic things, that the potential across a closed path equals to 0. So what is VAB? And what is the relation between potential and intensity? V is equal to minus E dot dl. So we know that if voltage is equal to 0, so we can write E dot dl AB plus E dot dl BC plus E dot dl CD plus E dot dl DE equals to 0. Sorry, this is DA. So you can see this is our EAB closed path. If we take this rectangle EAB into E dot dl plus EBC E dot dl plus ECD E dot dl plus EDA E dot dl is equal to 0. Now from this figure you can see that ECD is within the conductor. ECD is within the conductor, and anything is within the conductor means the intensity, the field is 0. Already we have discussed that we assumed that the intensity is 0 inside. So A to B plus B to C plus D to A equals to 0. Because it is within the conductor, and within the conductor intensity is always 0. Now already we got the equation. From there we can write, I will write here. So what is E dot dl? It is the tan. Already we have told in the previous slide. This is the tan component. So E dot dl means E tan into delta W. Why? You can see the width is given as the delta W. Similarly, if we integrate it, now, similarly, if we integrate the second one, means this equation, what will happen? Let's check. So, we have E B to C E dot dl. So, E B to C, what will happen? E, we can write, here is a point 2, you can see. So, we can differentiate the integration B to 2 dl plus 2 to C dl. We can write like this. Now, this 2 to C is again inside the conductor. So, the intensity is 0 here. So, we can take, and this is the which component? This is the normal component. You can see this is the normal component, parallel to the normal component, the orange one. So, we can write En. Now, what if the total length is h, this half length is h by 2. So, we can write it as delta h by 2. Okay. So, we got like this. Now, already we have discussed in the previous slide. That E dot dl, this equation is already 0, as the field is 0. Already we have discussed this. So, this value we got, this integration we have done, this integration also we have done. We have to do last integration. So, do the last integration from D to A. Okay. Integration of D to A E dot dl. Now, again we can see there is a point A. Okay. So, we can write E D to 1 dl plus integration 1 to A dl. Again, you can see that D to A is within the conductor. Within the conductor means again it is 0. According to our assumptions, it is again 0. So, we have to only calculate the value 1 to A. So, similarly, it is also, you can see, it is this color, this orange color. So, it is the parallel to the E normal. So, we can write E normal. And what is 1 to A? If the total length is h, half means h by 2. But one thing, we are taking the direction normally, but here it is in the opposite side. So, it is minus En by 2. As B to C, we are taking positive. It is in the opposite side. So, we can take it as minus En delta H by 2. So, if we go to the previous slide, so, what is the total intensity? You can see this is En by 2 and this is minus En by 2. These two will cancel out, and what will happen? The E dot dl will be delta W. So, this is the boundary condition. Now, we are coming to the question number 6. Define dipole moment and deduce its expression. What is dipole moment? A dipole results from the displacement of charges and the dielectric is said to be polarized. When a dipole results from the displacement of the charges, if we displace the charge from nearer to each other, what will happen? There will be a dipole change, and this is known, when the polarized charge will come nearer, it will create some dipole. In the polarized state, the electron cloud is distorted by applied electric field. When we are giving some electric field, what will happen? The cloud is distorted by applied electric field E. And this distorted charge distribution is equivalent by the principle of superposition, and we can write that the original, what is the charge? The dipole is known as the P equals to Q by D. What is Q? Q is the charge value and D is the distance between them. So the equation is, if it is for one charge, it is P is equal to Q by D. But practically there is a lot of charge in any conductor. We can write N is equal to 1 to K equals to 1 to N QK dK by delta V, limit delta V tends to 0. Next question. Explain the formation of dipole in electrostatic field. An electric dipole is formed when 2 point charges of equal magnitudes but opposite sign are separated by a small distance. Means if there are two charge plus Q and minus Q, the from 2 point charges of equal magnitude, means both are Q and they are but opposite sign. If one is plus Q, another one should be minus Q, and if they are distance is small d, what will happen? It will create some dipole. So when an electric field E is applied, the positive charge is displaced from its equilibrium position in the direction of E by the force F is equal to plus QE. It will attract the negative by the F plus is equal to QE. Similarly, the negative charge will attract the positive charge with the force minus QE. As a result, what will happen? The both charge will be like this. They will be deformed, and this thing is known as the dipole. So when an electric field E is applied, the positive charge is displaced from its equilibrium position in the direction of E by the force F plus equal to QE, and for the negative charge it should be force is equal to minus QE. This is the dipole. So we can write two opposite charge plus Q and minus Q has been separated by the distance D. So the distance travelled by the point charge is defined as the dipole moment. The distance travelled by the point charge while they are attracting both each and other, the distance travelled by the point charge is known as the dipole moment. And the product of the charge is known as the electric dipole. As I told, electric dipole P is equal to Q into D. P is equal to Q into D. Potential P is equal to the charge into the dipole, where P is the electrical dipole moment, D is the distance between opposite charge, and the line and the direction is the along the line of the axis of the dipole. You can see here we have written in the dotted notation. And a dipole results from the displacement of the charge, and the dielectric is said to be polarized. So the dipole results from due to the displacement of the charge is known as the polarized. Already we have discussed in the previous slide also. This is the main important thing of the dipole charge. Next, extract the expression for the torque of an electric dipole in an electric field. So you can see this is the field E we are giving. This is plus Q, this is minus Q, and this is the angle theta. So the force experienced by plus Q is F1 is equal to E into Q, and the force experienced by the second one is the second charge is F2 is equal to minus Q. So what is F1 plus F2? E1 plus Q minus E2 minus Q is equal to 0. So the force, the linear force experienced by the two charges equals to 0. But due to the force experienced by plus Q tends to oscillate the direction of E. So while the plus Q is attracting the minus Q, it creates some oscillation, and the direction of the oscillation is according to the direction of field E. This is the at theta angle. Similarly, minus Q also creates some oscillation, and due to the both side opposite side force, it leads to a torque of dipole. So if T is equal to magnitude of F, magnitude of the F means the force, or we can write E into Q. We are not taking the sign, we are only taking the magnitude and the perpendicular distance between their line of action. If the line of action is E, the line of action is according to the E. E means the intensity. So it is perpendicular to the E. So it will be E sin theta. So we can write E into Q. If the distance is R and angle is theta, so it will be R sin theta. So T is equal to 2R sin theta. Why 2? 2 due to there are two type of charge. One is positive charge, one is negative charge. So we can write again EQ into 2R. Q into 2R. Q into distance is nothing but the polarization. So we can, in the dipole moment, so we can write T is equal to P E sin theta. What is E? What is P? P is the dipole moment. Last question. Illustrate the expression for electric field intensity due to electric dipole. This is a very tough question actually. So what is this? While there is a two charge plus Q and minus Q, and they are separated by 2A. So what will happen? As they are separated by 2A, there are some potential, and the total potential is V1 due to Q at P, and for D2 it is V2 at P. So we can write V1 plus V2. Now what is V1? We know that the V1 is equal to K Q by R1. K is the proportionality constant, so K Q by R1. So we are taking first this triangle. What is R1? So this is a triangle of 90 degree, and we can take this position is XY, means this is X from the origin, and this is Y. So what is this distance? This, if this total is X, this distance is A. So this is basically X minus A. So we can write R is equal to X minus A square plus Y square. So what is V1? If we put the value KQ by root of X minus A square plus Y square. Similarly, we are thinking about V2. V2 is due to minus Q charge. So you can see minus KQ by R2. So we are taking this. Now we are taking this triangle. So again, up to this position is X. This is A. So what is the total distance? Total distance is x plus a. This height is again y. So what is the R2? R2 is x plus a whole square plus y square. So what is V2? V2 is x plus a whole square plus y square. And already we got V1. So V1 we know, V2 we know. So what is the total V? Total V is equal to k cube by root of x minus a square plus x plus a square plus y square. Just we are putting the value. Now, as we know, dipole moment happened when the distance is very small or the distance is nearer. So, we can write R is much greater than 1. Not, you can see 3 greater than sign means much greater than A. So, what we can think? We already got, if we think about the distance, root of x plus a square plus y square, we can substitute it by R. And we actually the equation is x square plus 2ax plus a square plus y square. And what is x square plus y square? What is x square plus y square? If we take this triangle, x square plus y square, this is nothing but the r square. So, we can write it r square plus 2ax. But as a square is very small, we can just cancel the value of a. So, we got square root of r square plus 2ax. Now, from this diagram, you can see if the angle is theta, we can write r is equal to x. If the direction is x, x cos theta. As this is the triangle, x cos theta. So, x equals to r cos theta. So, what will be the value then? If we just substitute the value, so what will be the change? It will be, the distance will be x square cos square theta plus 2ax. We can get the value root of r square 2ax. In the place of x, we are putting r cos theta. In the place of x, we are just substituting by r cos theta. So, this is our main equation. So, just we are putting the value v is equal to kq r minus a cos theta plus 1 by r a cos theta. And by the just simple addition, and after addition, we got the equation kp r square minus a square cos square theta. So, this is the value of the potential due to the dipole moment. If the question comes, calculate the field intensity, we have to add one more line. V is equal to E into dl. So, we already got the P value. It should be only multiplied with the length L. So, the equation will be KPL cos theta by r square by a square cos square theta. So, this is today's class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.